All right, so the last thing I'm going to talk about here is I'll just give you some guidelines as to how you draw a system design. All right. Now you can use any kind of tool that enables you to make block diagrams and colored lines and that sort of a thing. It doesn't what I'm going to talk about here isn't designed for any particular package. I use Microsoft Visio for diagrams like this, but you guys may have different choices, and that's fine. So what are the major steps here? So first of all, identify all your major components that are going to go into this diagram. I just showed you three different types of refined diagrams. So you need to understand in your particular picture that you're going to be defining, what are your major components going to be? What are all of those interfaces? What are their types? What are the relationships? What are the connections between these things? And then after you understand both of those two things, then produce your drawing. You should have components, should be boxes, which are labeled. Your interfaces should be lines with arrows indicating the direction. And you want to keep your layout as simple and straightforward as possible so that it is well understood. All right. So your major components, like we've talked about, you got a sensor system, a data archive, control, blah, 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 blah. Okay. So you derive these kinds of things from your goal objectives and requirements. Um, you'll probably produce many different versions. So that last lecture, I just showed you three diagrams, all of which are important in, for example, your PDR when you're discussing your system. That first diagram provides an overview of your entire payload. And the other two diagrams, you'd be doing something similar to that to all the rest of your subsystems. So you'll probably be producing a number of different diagrams, and you have to keep track as to what it is that's going to go onto that diagram and their interfaces. So first of all, here I've this is going to be a simple high-level system diagram of a payload. And so the first thing is that I identify all of my major components, and I sort of lay them out in a logical, straightforward fashion as we go here. And then I've clustered them into two parts. One part is what's actually going to go into the payload, and then there's another part which is not in the payload but is still associated with that payload. So in the payload, there's power, control, archive, sensor, and then there's also things like thermal control. All right, there is a thermal control subsystem that you're going to use, and there's a mechanical support subsystem, right? You can't just tape everything together. Well, I suppose you could. It's not clear that you would survive the FRR if you did that, but you're going to have some mechanical support subsystem and a thermal control as well as other things. And then on the ground, there's something that you're going to be doing on the ground with this data, and then there's data processing and analysis. So these are the major things. Now, how are all these things connected? Well, they're all connected in different ways, and you need to illustrate that connection. There's going to be wire or bolt or a thermal pad or whatever it is you're going to have to illustrate that and key it in a different fashion to illustrate these different interfaces. So, for example, here's one way to do some of these things. So power is sort of a solid black thin line. Data is a wide gray line. Control is a very thin solid line. Mechanical is a wide dashed line. Thermal is a dotted line. Okay. So that's one standard. point is that you pick a standard and you use this. Now, the other thing here is that you don't see any color here, all right? You can use color in your diagrams as long as you also have a different physical property on your interfaces or your box as well. Not everybody sees color in the same way, right? And in fact, some of your reviewers are not necessarily going to see color in the same way. And I guarantee that if you use only color, you are going to have lots of comments from that reviewer. So I would recommend you can use color to spruce things up, but don't depend on it, right? Now, flow is indicated with arrows, obviously. So two component would have arrow on one end, from the component would have the arrow on the other. Bidirectional, if you expect things to go back and forth on that line, would have arrows on both ends. So you do have to indicate the flow of whatever is on that. So add your interfaces. All right, so now we have all these boxes. Now we have our interfaces. So obviously, so here's our power interface, okay, in through here. Here's a control interface between the control system and the sensor subsystem, right? There's no control interface between the control system and the data archive in this concept, okay? But there is data flowing, you know, which are these thick black lines, right? So thick gray lines are data, right? Now, which way does all this stuff go, right? You add your line. So obviously there's probably some communication data flowing between the control system and the data archive, right? The sensor system, you probably are reading it out. You probably aren't putting data into the sensor system. Sometimes you might, okay, but in this case you don't. Ground system, you're definitely downlinking data or uplinking commands. And then obviously data goes into your data processing. In that you don't send stuff back up to the table, back up to the payload from your data processing subsystem. Likewise, you know, the thermal interface is a thermal interface to your, the thermal control system is a thermal interface to your payload. There's obviously some interaction between thermal and mechanical, et cetera. So this is drawn here basically to be that just to illustrate. Obviously, the mechanical support would be involved with all of these things too. But if you try to draw lines for all of that, you get really complicated. So this is an example of you keep things simple, a little bit simple. You identify that there's a mechanical subsystem, and you identify that there's an interface of your mechanical to your payload box, but you try to keep it simple. You can get more complicated if you wanted to go down to another level of the system diagram. All right, finally, you want to label. Everything in your figure needs to have a label. So this is 5 volts coming out here, 12 volts coming out there, 9 volts coming out there. This is digital, you know, digital data, which is coming through here. This is analog data. Analog and digital data are different. That's why they're labeled, right? If you really wanted to have a different symbol, you could do that, but you should still label it, et cetera. So you can see how this goes, right? So that is pretty much what you need. Those are sort of the rules in making these system diagrams. You want to keep it clear, clean. You don't want to get it busy. If you think that you're starting to get things a little bit too busy, make another diagram. Split out the subsystem, make another diagram, and expand the details there. Don't try to put all this stuff into one. Make certain that your diagrams are large and readable, and that your text is large and readable as you go through these things.